Second session of the Agile Industrial Day. The next speaker will be Alan Brown. Alan Brown is an IBM Distinguished Engineer at IBM Rational software. He is the Chief Technical Strategist for IBM Rational Design and Construction Products. He defines product direction and consults with product teams to help clients improve software development efficiency through visual modeling, model-driven code generation, and systematic reuse. This involves working with engineering teams on product architecture, product management groups on creating plans, and marketing and field teams on positioning IBM Rational products and services. His primary interests are in service-based design, component-based development, software engineering environments, and enterprise application development tools. So, Alan, it's your turn.
Thank you. So thank you for inviting me here to talk this afternoon. I thought what I might try and do for the next hour or so is give you some examples of how we're addressing some of the challenges of applying agility at scale in some of the clients that IBM is dealing with. And I think many of the same themes from this morning will be repeated in this presentation. So I think hopefully this will reinforce many of the same ideas, many of the same challenges. But I thought it might be important if we start off by looking a little bit at how software is developed by IBM itself. IBM is a large organization, probably 350,000 people in IBM, 1/3 people, which is a big organization. So we have a lot of people developing software. So it's quite interesting to see how we're looking at the challenge of global development, of being more agile, of responding better to customer needs, and then also how we're trying to apply that knowledge to clients and customers. So I thought the first thing we might do is simply go and see what our development labs are doing right now. And in the past, of course, this was a challenge. It's still sometimes a challenge. But it's interesting to see how the technologies have moved along. And when we want to go and see today what's going on in the development labs, which products are they working on? What's the current status of those products? Which bugs are filed against which products? What's the current quality of the releases? What's the plans and how have those plans changed over the last few days? We can do so, of course, relatively easily these days. So let me just show you. It's going to be hard to do this with two hands, but let me try. That wasn't my heart beating. So if we go to, this is something you can do too. You can go to jazz.net. And jazz.net is the portal to our development tools. And you can see that at the top here are a bunch of projects. These are the projects that we're working on right now inside our labs, some of the tools that we're producing. So we can look at one of those. Let's look at a product called Rational Team Concert. And if we go and look at Rational Team Concert, there's the usual publicity blurb nonsense. And then we can go and say, I want to see what's going on. Let me see the project dashboard. Where are we right now? And this is going to our labs servers. These servers happen to be based in Toronto, where we've got one of our larger labs. And this is the current development status for Rational Team Concert. You can see the different releases. You can see where we are in the various phases, which defects have been logged against which systems. You can see what the outstanding work items are for each person. So we can start to take a look at some of these. 3.0 has just come out, so maybe we should start to look at some items here. So if we pick an item and we want to look at some items that we're currently tracking that have been logged, I don't know what these particularly are because this is a real-time information. So let's pick one of them and let's see what it is. So up comes a work item. Somebody's obviously logged some issue here. We can see what this issue is eventually. And this will give you some information about who logged a problem, maybe. Yep. It's a build item, track RTC 3.0 iFix M1. This is a build item, which stream it's on, the description of it, where it's deployed. We can see some quick information about who's interested in it, where it's mentioned, who it's connected to, which subscribers. We have 125 subscribers to this particular build event. We can see it was filed against Release Engineering, who it was created by and when. We can go and look at the approvals list and the history for this. So we can go see, because there need to be sign-offs for a lot of these things, who approved it, what sign-offs we had. This is, again, live information about a worldwide team building a series of commercial products. And what's interesting is we're starting to see the infrastructure in place to support large-scale collaborative development across teams producing commercial software that helps them to be more effective in how they communicate and how they establish links. Clearly, with internet access, you get what you pay for. So what we're beginning to see is an interesting infrastructure beginning to appear where we can begin to assess lots of interesting things about the products, the builds, the particular people working on the products. Let me go back and pick some of the plans here. So if we pick, let's look at some of the defects that were logged. Which defects, which are must-fix defects, which are work items, which are documentation issues. So we can, let's see which work items were logged. We can go see who they were logged against. So this is the kind of system that is being used worldwide by our teams that we're delivering to other people. You've probably seen other systems from other organizations producing similar things. This is something very different than the way we operated just a small number of years ago. These kinds of systems are revolutionizing what's possible and how we're organizing, what we're delivering, and how we're delivering it. So this is what I want to spend the next few minutes talking about. How have these systems come about? How are they being designed with what features? And in support of what? What kind of development approach for our organizations? So that's what I'd like to spend time doing. The other thing that's interesting is, very consciously, this stuff is transparent to our consumers like you and to our competitors. Anybody can go and see this. So you can see which bugs are outstanding on our products. You can, we can, our competitors can, without any restriction. And this is also a very interesting change in philosophy with its own implications, as you can imagine, which we might talk about in a minute. Okay, so that's enough of that. Let me go back to the slides. Okay, so let me start by giving you a summary. I'm in danger always when I give a presentation of never reaching the end. So I've got a solution to this. You show the last slide first, and then you can always claim you came to the end. So here's the conclusion. If you fall asleep after this slide, at least you'll have one thing in mind. If we look at the way agility is changing commercial organizations like IBM and our customers, we are focusing on 3 areas that we believe are the essential areas to help them to adopt or adapt, perhaps, some of these agile ideas at scale in the kinds of contexts that Philippe talked about. The first is about collaboration. If nothing else, the Agile movement has told us that we have to work as a team. So all the stuff about self-motivated teams, single team thinking, being able to react quickly as a team, stand-up meetings. It's all about communication. It's all about your teams collaborating. And as we know, if it's 5 people in a room, that means one thing. If it's 500 people across the globe, that means something different. But the idea of collaboration is absolutely critical. And we know that the more we can interact, the more we can exchange information in some reasonable way, the more likely we are to avoid many of the mistakes that occur in developing large-scale systems. I thought you knew that we'd already decided this. Oh, I thought that was documented. We know how poorly we document. Oh, it was in the previous release. Didn't you see the note? All of this stuff that happens, we're trying to overcome. And the collaborative infrastructure helps us to do that. The second area is about automation. And you might say, well, you're a tool vendor. Of course you'd say automation is critical. But one of the things that we see more and more frequently is that when we want to try and move quickly, when we want to try and be more effective, maybe it's more agile, maybe it's more flexible, we have to be able to get rid of the small things that get in the way. Oh, we can't test today because the build last night failed. because somebody forgot to check something in, or the build script broke, or there was a problem with the server on which the software was installed. So we can't run that test. We'll have to do the build tomorrow night, and then maybe the night after that we'll be able to do the test. If you're trying to work in an agile way with very fast cycles, you just can't afford the time to wait. Oh, the team hasn't woken up yet in India, so they won't get to putting that stuff on the server until tomorrow, and then we can ask them the question, and then we'll get a response within 4 hours. You can't afford to do that because you lose days in a 2, 3, 4 week cycle, and that's a large percentage. So you have to have an automation framework that helps you to support test-first development, continuous build, immediate feedback from the things you're doing with your stakeholders, particularly if your stakeholder isn't in the same room or the same building or the same city. The third area that we think is critical if we're going to make any progress here is visibility. The other major weakness, I think, of agile approaches is it assumes that we can make decisions more frequently, that we make better decisions. If every day we're having a stand-up meeting and a review, if every week we're having a retrospective, if every month we're having a review of the product and its direction, you better have some reasonable data on which to make decisions. And right now, decision-making within our industry is very poor, normally because we don't have great data. And when we do have reasonable data, we don't really know what it means. So we make our interpretations of what some of this trending means based on perhaps limited experience, let's say. So it's very critical that once we start to move more quickly, once we have teams that are more flexible, once we use people around the globe, we actually have a better view, a better insight of what's actually going on. Because we're going to have to make a lot of decisions very quickly. Do I stop this? Do I accelerate that? Do I move this into the next iteration or sprint? Do I start to do something different at the end of the sprint because of a retrospective that said this didn't work well? We have to be able to be more effective. So these three things for us are critical. Focus on these three things, whether you use our technology or anybody else's, whether you're working in 5 people building a very stable kind of system, or whether you're 500 people working in a very dynamic system. Focus on these 3 areas, and you will make progress on being more flexible, being more agile, and being more effective. So for us, this has been the critical revelation, if you like. So that's what's underlying a lot of what we've done. So if you want to fall asleep now, you can do so. So let me ask you a quiz first. And Philippe, you can't answer this because you know the answers to these. There are lots of people who have more hair and certainly are not going as grey as I am. So you may be interested in hearing a little history around this. But what is this picture? Does anybody know what this picture is? I mean, it's obvious when you look at it what it is, but any quick suggestions? We're all too sleepy, huh? Puedes decirlo en español si quieres. Okay, so this is the development life cycle. And it's the hump chart that was made famous by Philippe and colleagues in RUP. But this is a diagram from 1967. This is the diagram that comes from the original NATO reports that was done, 67, 68, Brian Randall and team. And if you go to that document, I was just looking at it the other day for various reasons, and this is a diagram pulled directly from it. And the reason I want to show you this is I want to do some looking at today's projects, and I want to compare this to that. But what's interesting, of course, is as Philippe showed, and I swear I didn't know he was going to do this, how were we programming then? This is what we were doing then and a few years later. This is, a Hollerith card, a punch card. And for those of you who haven't seen too many of these, I remember when I was in university writing programs using these cards. Printing these cards and the whole signify a coding that can be read by machines. And an interesting story. I remember I think Brian Randall told me the story and swears it was true. I disagree, but he claims it was true. So many years ago, when they were doing the first software for doing man-rated machines like NASA's space stations and some of the rockets and stuff that were going up there, they used to do software on cards. And like most things, when you had software and hardware and everything else that goes onto a piece of equipment, they had to weigh it all to see how much the final system would weigh. So a guy showed up with his clipboard into the software department, as it was then, and said, okay, I'm here to look at how much everything weighs. And I've got a line item here that says, how much does the software weigh? And they kind of laughed and said, what do you mean? How much does the software weigh? Yeah, I have to write down the weight of the software that's going to go on this vehicle. And they said, it doesn't weigh anything. What do you mean, how much does it weigh? No, I have to write it down. How much does it weigh? So after a discussion, they managed to convince him that it didn't weigh anything. So off he went, he put a 0. The next day he comes back with a big box full of these cards and said, look what I found. You said the software doesn't weigh anything. I found all of these cards and I weighed them. It's 4 kilos. So I'm going to write down the software weighs 4 kilos. And they thought, oh man, what are we going to say here? And one bright spark said, no, but the software's in the holes. So then he was happy, so he put a 0 down again. So the software's in the holes in these cards. So what is this? Well, this is what we get shown when we go visit clients and they say, this is the architecture of our system. And it doesn't matter you can't read the boxes because it could be a business process diagram, it could be a component diagram, it could be a layered architecture, they could give it any name you like. But this tends to be what we see. This is an actual diagram we were given by a computer electronics company that said this is the design of our system. And then they say, and we've got to decide how to save money on maintenance. We want to cut maintenance costs by 10%. What should we do? Okay. We're looking for dead code and we're trying to decide how we redesign the system. Where should we start? Okay. We want to outsource it to India because we think it'll be cheaper. What should we tell them? Okay. These are interesting questions. But this is the kind of situation that we find ourselves in mostly. It's not nice, pleasant, greenfield situations. It's what they call brownfield. It's kind of muddy. So we have to try and understand this, and we have to try and work our way through. So we know that there's lots of challenges here as we look at system architectures from any perspective. And we have techniques that we use in order to try and understand this. But the problems, of course, are from multiple levels. And what I want to try and give you a sense of is at least 1 or 2 of the dimensions of this. We only have an hour, so I'm not going to go into a lot of detail on all of these. But let me just pick a couple that are particularly important right now in the situation we find ourselves in. And of course, the most obvious one is let's pick geographic distribution. As I say, IBM is 1/3 of a million people. And about half of those are consultants in global services. So 160,000 people go out and try and help, I'll be polite, try and help organizations to develop and deliver large-scale systems. So we have a lot of experience from those organizations, and more we're using people in different parts of the world for lots of reasons, because labor is cheaper, because skills are more accessible, because it's closer to the client. There can be lots of reasons. But the result is that we're using more labor around the world, that all of the people we're working with are doing that. And it's not a hard thing to understand. You look at the labor rates for somebody in Europe. So for example, if we go with somebody from GBS and we say, this person's 1,000 euros a day, or we can employ somebody in India for 100 euros a day, which would you like? Now, it's not hard to say, well, maybe they don't have enough experience, we have a communication problem, we're going to have to get on the phone, there's a time difference. Yeah, but they're 1/10 of the price. So people go through those calculations, and particularly if it's more of a financial-oriented situation where they're trying to save money, which if you live in Spain, you don't have to look in the newspapers very long to understand the crisis. So what tends to happen is we see these sorts of diagrams which says we're using different locations. Here's a very simple view with 3 locations. What we might call on-site, our European offices. What we might call near shore, it's not too far away, the time zone difference isn't too difficult. Maybe it's even part of our own organization. And offshore, we're using places, it could be South America if we're working in Spanish. It could be other places like India and China. And there tends to be a division of labor across those locations. And there are different patterns. This is one common pattern that we often see, where this is where some people, maybe the term was software factory was used this morning. A lot of organizations that are using labor in Asia in particular and South America are thinking about these offshore locations as their software factories. This is where we build the code that gets delivered to our onshore locations that are responsible for delivery into production. So when we see this, this is what I sometimes call the knowledge donut. There's a big hole in the middle. The big hole in the middle says, where's the knowledge about the detailed design in the code? It isn't in the headquarters of the organization onshore anymore. It's in your offshore location. It's in your system integrator. It's in the third-party contractor that's outsourced to another country that's outsourced to another country. So you say, but don't worry, we've got documentation. Ah, okay, great. And the documentation is complete and accurate, reflects what you need to know about the details of the code. Not really. It's kind of a little old, and when we ask for documentation from the team in India, they basically just give us the comments that were in the code. They don't actually give us architectural documentation. The architectural diagrams that we have, they're sort of in UML, and there's 174 use cases, so it must be good, right? Well, maybe. Depends, you know. So we have a challenge here. You also look at system integrators like Wipro and Tata Consulting and those guys. Some of them have up to 50% turnover a year. So the knowledge isn't even in the people, because they've gone. They're in another system integrator now. So you have this huge issue of where's the knowledge? Where's the information? Where's the history? And it's not the way it was a few years ago. You go and ask George, you go and ask Sue, you pick up the phone and say, remember that stuff we worked on last year? Wasn't it that issue that we had to You can't do that when it's somebody in Bangalore who's changed 3 times. And also, by the way, you contracted somebody else because they were cheaper. So that knowledge has disappeared. It becomes very, very complicated to try and operate in these contexts. And this is just one example, a very simple map. By the way, even with this level of discussion, I've gone to some organizations where you talk to 3 or 4 different people, the finance people, the architecture people, some of the lead development people, the QA people, and say, draw a map of how you're using your different resources in different locations. And you get very different pictures of what they think is going on and where the knowledge is and what transfer of information needs to happen and how, even at this level. So let me take a real example. This is sort of an abstract example. Let me take a real example. Let's pick a project. Let's take a large, I can't really use their name, I suppose, a large organization based in the Netherlands that does oil and gas. And let's assume that they do a lot of use of system integrators. And one of those system integrators happens to be IBM. So we have a little insight into some of their projects. Let's pick a project and look at it and see what happened. And this is a project where it says here it's about more or less 3,000 man-days of effort. It took about a year. There's a big game, of course, between onshore and offshore resources. And the big game is, if I use more offshore resources, I save cost, at least labor cost. But it increases the communication costs. It increases the problems I have perhaps with things like architecture and governance, so I have to put more energy, more effort, more money into those things. It means I maybe have to do more inspections. So there's this big game about how much onshore, offshore kind of mix can I use, and what's the right process and management and governance approach to make sure that that works. As Philippe was saying, this is a balancing act that we go through about risk, about cost, about quality, and about our use of resources. So there's different things we can look at about how that mix would change our investment. But let's look at what they actually did. Remember my diagram from 43 years ago? Kind of looked like this, didn't it? That late in development and into the testing phase is when we see the peak of activity. That it's getting things from, we're almost code complete into the integration test. Integration test. Those guys didn't really understand the architecture that we defined. Oh, the definition of the interface wasn't quite the same. All of those things that happen late in development when we're starting to bring all the pieces back together, and we begin to maybe, for the first time, start to see what the system does. we get more and more stakeholder input. Is that what we said? We didn't really mean that. Oh, okay, well, that's what we built. Well, we need to quickly fix that because that won't do. We won't be able to get that released. So we have this big spike of effort late in the implementation development stage as we get into test. We do as much testing as we can, and we kind of declare success, and if we can, we try and release it as close to the deadline as we promised. And this is typical, and this is what actually happened. These are the people, this is the time they build on the project. So when we look at this and we say, if this is a typical project, how would Agile help us? What would it do to help in projects like this, that are of this kind of scale, at this kind of profile? Where would we focus? What kind of changes would be needed? We're not just doing Agile for Agile's sake. We're doing it because it helps projects like this. At least this is one class of project that it can help. So let's think about that. So we did a lot of analysis. I won't go through all of the analysis. There's some stuff I can send if you're interested, to say how and where would we look to help this. And of course, there are 2 or 3 things we want to do. The first thing we want to do is we want to try and reduce that peak that happens late in the development stages. Now, many of the things that are in the Agile manifesto and Scrum and XP and so on are about attacking that. Test-first development is about not waiting too late. Continuous build is about making sure that you've got a continuous, healthy system. Making sure you get whole team thinking so the test people and the deployment people are involved early in the project. All of these ideas are about helping that problem so you don't get such a spike late in development. The second thing they're about is pushing the time in. If we can reduce scrap and rework by doing continually refactoring, by rethinking the architecture early on so that we have a good solid architectural baseline, attacking risks early, all of these techniques that we know about, we can begin to push the time in to delivery. And therefore, again, we avoid a lot of the cost, which spins our test cycle to be too long and to miss our deadlines. So these are the kinds of things we can look at. And in fact, we can look at the analysis of what we do. A couple of interesting observations. One is, you may actually have to spend more time at the front than you expected. And to many people, this is obvious. If you're going to outsource a project, if you're going to be more iterative, more flexible and agile, if you're going to make decisions more quickly, you'd better make some decisions up front about architecture that are going to stick, because you can't have everything changing all the time. It doesn't work that way. You'd better get some communication channels in place that allow your teams to be effective. You'd better understand the governance mechanisms. You'd better make sure that you have some sort of risk-based approach to how you're going to move forward. And that costs effort. So you have to invest a little up front. So there's various things we could look at here, but we see a different profile starting to emerge, or at least we start to see how we can begin to attack some of the problems. Now, this is a very high-level, 3-picture kind of cartoon of a very large-scale analysis. But this is the kind of analysis, I think, that we need to spend more time on, understanding where and how we can see changes. And I think there's a lot more work still to be done here. But it gives you a flavor of the challenges we see in certain classes of project, the pressures we see, and how we think we can address those with some techniques. So there's various areas where we see the changes, how the effect in quality, the effect in data management, the effect in requirement traceability, and so on. That leads us to those conclusions. So I've not said too much yet about Agile, but let me just give you a view. Given that kind of context, that's the sort of world I come from. That's my blinkered view of the world is based on projects like that. What does Agile mean then? What does Agile mean to somebody coming from that world? Well, if we take a traditional sort of waterfall style view, and most projects that I'm involved with, whether they say so or not, they more or less follow this V model. You do a lot of work up front to understand what you're doing. You then start to do it, and then you test and deliver it based on a series of validation efforts. And that gets you through to the process where you can release. Most projects have that sort of profile one way or another. The challenge with that, as we know, for those of you who are familiar with things like the capability maturity model and other sorts of models, what they've tried to do is they've tried to say, how could we optimize processes that look like this? So if you take the levels of the CMMM, for example, level 1 to 2 focuses on management. Level 2 to 3 focuses on some engineering practices. 3 to 4 focuses on some measurement. 4 to 5 focuses on some optimization. But it's based on a fairly rigorous, well-defined process. And all the studies that are done at SEI and elsewhere, what they show is you can improve the quality of what you deliver. You can improve aspects of the productivity of what you deliver. None of the studies really show any improvement in time to market, because that's not what it's about. It's about being able to more repeatably produce systems in a more effective way. So what's happened in the last few years is, of course, there's been a sort of reaction to things like CMM that says, but what if I'm in a project that isn't software in the nose cone of a missile? It isn't that kind of project. It's about getting things out quickly, on time. And perhaps I see the difference between what we might call delivery risk versus operational risk very differently. What I mean by that is operational risk is if I deliver it and it's wrong, people die, as Philippe was saying, or I lose $1 billion. I better do a few more checks. I'd be a bit happier. Get a few more people to sign off. Do some more documentation reviews. Versus, no, if I miss this deadline, then our competition will steal the market. I will not be able to release it on this phone at the show that's going on in Stockholm next week. There are certain things about hitting deadlines that are becoming very critical. So what we call operational risk, the risk of killing somebody, versus delivery risk, missing a date, can be viewed quite differently in different organizations. So for them, things like CMM, CMMI became difficult for them because it meant rigorizing things that perhaps were not the optimal way of delivering solutions. So they said, no, 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 this isn't the picture. This is the picture. Push it in. I've got to push it in. I've got to push in the deadline. So there's a joke that we have in IBM in some of our projects that said, if we delivered the null project, we actually didn't write any code, but followed all the steps, it would still be 6 months. And we haven't delivered anything to go through the reviews, the sign-offs, we have certificates of originality, we have 100 things. Even if there was no code, it would still take 6 months. But the deadline's 3 months. So how are we going to deal with that? So we had to start to think differently. And lots of organizations have had to start to say, all of our projects don't have the profile that supports a large-scale, robust, repeatable kind of approach like waterfall, particularly supported by maturities like CMM. So how do we deal with those? And the answer is, again, figuratively, just for our little discussion, imagine you go to the top diagram and you push it in. Right, we're going to deliver in 3 months, not in 9 months. Okay, you don't have to think about architecture any less. It's still important. You've still got to write as much lines of code, maybe, more or less. And you've still got to test it as much. So these two, the top one seems to have moved. These two parts of the V, you still have to do them, but now you've got to collapse them. You've got to start to do things earlier on, not wait until the code's more or less done before you start to do too much testing and documentation, integration management, starting to get acceptance tests. Push those early. Start to think about testing early. Start to do test-driven design. Get people involved early. So if you start to do this, you can start to get more parallelism, shall we say, or at least more interactivity in the teams. But it doesn't come for free. If we start to do this, this gray area means lots of things are going to go on at the same time. I'm testing stuff as I'm building stuff. I'm redesigning stuff at the end of every week or at the end of every 2 weeks. I'm starting to rethink the requirements because they weren't all stable when I started. Naturally, I didn't wait till all the requirements were fixed. So I'm going to start to be doing lots more things at the same time. In most organizations, this is a disaster because we're not good at doing this. Our requirements people don't talk to our design people. Our design people don't talk to the coding people. Our coding people are in 3 different continents. Our testing people are a different organization because we outsourced test because it was cheaper. But they're in a different continent now and they don't understand the context in which you built the application. So how is this going to work? So this gray area, if you're not careful, means you're in disaster. It'll just lead to chaos. So you have to start to say, in order to deliver this, we've got to put some sort of collaborative platform so you can communicate. We've got to get some sort of visibility to make these decisions. We've got to be able to plan more effectively. Our planning meetings are mostly a joke. You go to your end-of-week planning meeting, which somebody has spent 3 days producing charts for. Green, 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 green. The week before the deadline, red. Okay, this isn't good. What is this? Well, we kind of, until 2 weeks ago, we were really hoping we'd make it. We thought we could. If everybody really worked night and day and the requirements all came in, we thought we'd get there, so we put green. But there was a 90% probability that you wouldn't. Yeah, but we went for the 10%. And that's the way we often do planning, right? It's not based on the realistic assumptions of what's likely to happen. It's based on what we really want to hope to happen, maybe will happen. It's a new verb tense, the future optimistic. So this future optimistic view isn't acceptable. So you have to have automation, measurement, a closer customer relationship, whoever the customer happens to be, and more project visibility so that you can plan more effectively, so you can visualize more effectively. That's the only way that you can succeed. Now, if it's 5 people, I have to say, seeing the presentations earlier, the sort of, I've been working in software tools for a long time, and when you see pictures of people using stickies on a whiteboard, somehow it makes me feel very nervous as somebody who's produced software tools for the last 20 years. Can't we do better than this? Is stickies on a whiteboard the best way? But sometimes it is, right? When there's 5 people in a room and you're having an interactive debate and you want to draw something, pulling out a tool and drawing it on a sketch pad, and I've got my drawing tool up, and is that a box? Oh, hold on, which color do you want that in? No, just quickly, we want to get the ideas out. So when you're in a small team, that's fine. How does that scale, though? How does that scale to 100, to several hundred people, or to 10 people that happen to be in 3 continents? So these sorts of things become much more difficult. How we interact, how we move, how we operate. So this becomes very much more interesting. What is this agile delivery process platform? What does it look like? And what can we do in order to deliver on that? So the title promised quality, so I thought I'd better say something about quality before we get too far. So I'll give you an example of that in a minute, but I want to talk about quality because I want to take a broad view of how taking this approach actually can help us to improve quality. And when we think about quality, it's easy just to get pushed into thinking about testing. And I want to just sort of stretch the idea of quality just for a second into 4 areas. For us, certainly in the work that I'm doing with clients, 4 areas become really critical when we want to talk about quality. The first is, if we want to improve quality, we can improve it by automating. And a lot of the repeated tasks that we do can be more effective if we are able to automate some of them. So obvious things like build scripts, obvious things like test scripts and regression testing. These are still largely unexplored territory in many customers. You might think this is crazy, but a lot of the customers that we deal with still don't have many large-scale regression tests that are done automatically. They still don't spend an awful lot of time automatically generating information from existing systems on which to make better decisions for the future. And you'd think, well, why not? It's actually very hard to do. To automate a lot of these very complex processes, the kind of diagrams I showed earlier, it's not simply a matter of we'll write a bit of Perl script here and a bit of Python there. It's not, life isn't quite like that, unfortunately. So they spend a lot of time trying to understand how to put some of this automation together. So build automation, test automation, configuration management are areas where there's still a lot of improvement. By the way, there's a lot of discussions where we get to talk with mid-level managers and CIOs. And they say, literally, particularly these days, they say, I have to make a 10% cut in my budget by the end of the year. What should I do? And it's a very interesting exercise. What would you say? You know, you're in your favorite tapas bar with your copa in front of you, and they say, come on, tell me really, what should I do? Where should I focus? What would you say to them? And the first thing you could say is, well, where will you see the most benefit most quickly? The back end of the life cycle. Start on test. Start on the sort of quality areas. Put some automated regression testing in place. Start to help your people to manage their test lab equipment more effectively, to be able to spend less time looking for which machine shall I run these tests on. You can quickly put improvements in place in those areas, and you'll see the benefit within weeks, because the time from putting those improvements into place versus something being delivered is usually quite short, and you can measure the difference. fewer calls on your hotline, higher quality, lower defect rates. Those sorts of things are really important to organizations, so you can see the improvements very quickly. So the automation becomes the first thing that you could focus on. The second thing is, of course, the defects come from somewhere. And usually, as we all know, they come from early in the life cycle. Misunderstandings about requirements, problems with design that show up late on. And we know to fix them late on is quite costly. Fixing them earlier is much, much cheaper. So understanding then the earlier part of the life cycle also has a huge impact. Of course, this is why we spend time in requirements management. This is why we do UML modeling and all this stuff, to try and understand what it is we're trying to build, the intent, as Philippe was talking about it. And the effectiveness then becomes important, and you can measure that. You can look at requirements volatility. You can look at the amount of change in the designs. The third area is by looking at what the customer was asking for and the alignment between the different parts of the business. So this time to market is normally a reaction to what the customers are asking for. And you know, most of the experiences that I have with customers, you go to the engineers and you say, why aren't you spending more time talking to the requirements guys and your business analysts and the stakeholders? And the answer is quite straightforward. They say, well, on the few times that I actually understand what it is they're talking about, they don't understand my answer. Because they're talking a business language and I'm talking a technical language. And by the time I've understood what it was they wanted and the implications on the technology, I explain it in technology terms. They say, don't give me this gobbledygook, just make it better, quicker, faster, cheaper. And this translation becomes very hard. So this is where this alignment becomes really important. We spend a lot of our time going back saying we never quite understood it, or they didn't express what they wanted clearly enough. And then the final thing is about the variance in the projects. If we could understand how long certain things take, we can plan effectively. But right now, our planning and our management of projects is very poor. So if you go back, you know, everybody says, yeah, but we have Kokomo and Barry Beam's work on those models and Capers-Jones. We've got a lot of statistics now. If you go back and look at Kokomo, I think it said something like, these numbers come from a series of projects, and 50% of the time projects are about they follow these profiles about 25% of the time. There's a huge variance in the data that is used in models like that. So they give you an indication, but they're not very useful in pinning down what happens in your particular context with your projects. So getting data around that becomes really critical. So this becomes the key area. How do we get better information, more consistency, more predictability in what we're delivering? So these four areas are what we mean when we talk about quality, by making things more efficient, more effective, more predictable. And of course, the big thing is the cost comes late in the life cycle. They're often caused early in the life cycle. And we know these sorts of curves, right? This is the kind of stuff we've seen in our software engineering classes and in our experience in industry for many years. So the focus is these three areas. This is coming back to the point. This is why these three areas become critical. Communicating more effectively, automating what we can, visualizing more effectively. So let me give you an example. Let me give you a real example from Rational. So Rational is we're about 3,000 engineers, more than that if you count all of the sales weasels, but about 3,000 engineers. And we're in lots of places. And we're in lots of places for lots of reasons. You know, originally it was because people like Philippe wouldn't move from Vancouver, or we've got one poor guy down in Australia, you know, who won't move. We've got lots of reasons why people are in those locations. Of course, lots of people now in China and India because we're trying to manage cost. We have lots of acquisitions that have happened, so people have come from different places, and naturally we can't just move hundreds of people. So we have a very diverse organization in lots of locations. So what do we do when we develop solutions? Well, I'm going to go into a small slice of the problem, but I just want to give you a broader context. There is a product delivery process that says, how do we decide what to build? For some people, it's a shock that we have a strategy, but we do have a product strategy here at Rational. And it's based on a series of stages of looking at the market, of deciding what competition's doing, of looking at business value, of looking at profitability. So there's a whole process about how we understand what we should build. I'm not going to go into the details of all of that, but just bear in mind that's a very important and complex process in and of itself. But I'd like to talk a little bit about the project development and delivery process, this yellowy part. But remember, it's in this broader context. So I had a little discussion, a fair and frank exchange of views about whether I should show these numbers. But when we looked a few years ago at the state of our delivery inside Rational, it wasn't a particularly optimistic view of where we were. The numbers that we were able to show them was that we were an organization in some difficulties in terms of delivering quality products that our customers wanted in the time frames that they wanted them. And I think it's for all of the reasons that Philippe mentioned, that you reach a point where you're a large enough organization with a large portfolio of solutions with many millions of lines of code, and you naturally kind of grind down to a pace and a way of working that is not very innovative, perhaps, and certainly not at the kind of the pace that you would like to deliver new capability in the relationship to the markets that are changing quite fast, particularly as we saw over the last few years with things that have happened with the technology, such as internet, with the business world changing very fast around us, with open source competition, of course. It's hard to compete with free. So those sorts of things pushed us very hard. And when we looked at our own organization, it wasn't a particularly pleasant sight. So we did a number of things, part of which was to do with Agile. So we needed to change. We needed to look at things like agility. So we took inspiration from several different areas, and we started to move our own organization and our own products. First of all, of course, we looked at how we were developing solutions. And the first thing that we recognized is the contextual aspect of the process itself. Yes, we're a commercial development organization. Yes, we have to have sign-off. We have to make sure that we're doing things like open source kind of usage correctly because we're a large target for litigation. Yes, we have to make sure that contractually and morally we're doing the right things in terms of working with partner organizations. So there's lots of things that are important, but it doesn't mean that everything has to be done at a slow pace, at a very high governance, high conformance kind of way. We have to try and match the processes to what's going on, the teams, the situation. So we started to look at where there was variance in the projects themselves and how some ideas around iterative design, agile design could be used in our own organizations. And we started to break things down into a kind of development approach where we looked across the different roles, business analyst role, so the people who are trying to understand what we should build, the people who are building it, and the people who are responsible for making sure we're shipping the right things in the right way with the right quality. And to link those three things together in a more effective way. And I'll just give you a thumbnail of the way in which we're working today by showing you an example of a team and what they're doing. The first thing is we're collaborating in a different way than we did before. Every project that I know of at IBM involves different locations. And again, as we said earlier, this doesn't always mean different countries, but it certainly means different cities, different buildings, even different floors of the same building can have a very different culture and a very different view on life. So we always have distributed projects. Quite often we also have organizationally distributed projects where we're using another organization to deliver a piece of this solution. So this part of collaboration becomes really critical. These are some screenshots from one project where we have presence awareness. We have the ability to see what somebody's working on right now. We have the ability to communicate effectively in context, which means I'm working with you, you happen to be in another location. And I want to say, hey, that build that failed last night, I was looking and I think this problem is this. And I want to be able to send you a build script. Not send you email that points to something in a repository that tells you what the password is so you can check it out, so you can take a look, so that you can then send me email. So that, God, we don't have time for this. I want to be able to push that into a chat session and you get a link that you can open that shows you everything, that takes you to the right place in the data. That kind of stuff, it's not hard to do today. Yes, there's some things about security and other issues you have to deal with, but the technology is there to do that. So building that into the system becomes really critical. And lots of things become possible when you put a collaborative environment at the heart of what you're building. So this shows you some things here about how we work, how we look at different things. On the right-hand side, of course, is about the planning. As we know, in any sort of agile kind of approach, if you go to the daily meetings there, the daily stand-up meetings, there's a different feel to the way progress is assessed. You know, the status meetings from traditional projects at the end of the week or the month, it's all about who can we beat up today that isn't delivering, that failed to meet their deadline, because I want to make sure it's not me. Whereas the sort of daily meetings, it's much more about how can I help to make sure that we can be effective. If this guy's struggling because he didn't realize the problems that he was facing in trying to fix these bugs, maybe I can take one of them off him. If there's a problem because we don't understand how to solve this problem, maybe we can get a meeting together and we can go and work out how. There's a much more collaborative feel. And this kind of information really helps. Stand-up meetings, in theory, stand-up meetings, with people who are in different locations around the world using this information. Who's working on what? What did you do yesterday? Where are we on some of these items that are on your list? How much time did you estimate for that? Is it really that long? I think it must be longer. We can have those discussions if the information is visible and available, and you can't always be around a whiteboard. Checking the status and the health of a project. I showed you just a little bit of the jazz.net. Go and take a look. You'll see lots more information like burn down, like velocity, all of these things that we know give you a health check. You know, a project I was on not long ago where we're on the phone with a team, it happened to be in Istanbul, that was going through a review of something. We spent 3 hours doing a design review, and it's yes, yes, green, green. We all put the phone down in the room and said, do you have any confidence this project's on track? No, it's a disaster. What did we just do for 3 hours? Why did everybody nod their head and it was green when we know it's a disaster? Well, there's things that we know that just give us that feeling it's going nowhere. You know, the builds aren't regularly being successful. The team isn't communicating right. You see some trends in the way in which defects are being handled. They're not really talking to the other groups the way you would expect. There's certain things that we know that tell us of the health of a project. So are there ways that we can begin to look at this and look at some of the activities and see some patterns here that we can detect quite easily if we have some collaborative environment underneath? Of course, sharing the information, the code, the builds, having the infrastructure underneath so we can check out effectively. We can look at streams. We can look at continuous build and build health. Tracking tests to this, being able to look from a testing and a management point of view so that we can see from the test team, from the development team, from the requirements team, they can see the same information. They're working off the same sheet of information. Being able to look at a central set of information, whether we're using different test systems or not, that we can still see a dashboard of what's going on. And of course, being able to understand the early stages of a project. You know, with all due respect to the tools that we've built in the past, things like Requisite Pro and Doors and so on, those sorts of requirements tool, more or less, they're a spreadsheet that sits on a database with some reporting. They're kind of nice spreadsheets that sit on database with reporting, but that's what they are, because they're about managing requirements lists and creating those lists and linking those lists and being able to report on those lists against various criteria. That isn't everything about requirements management and requirements definition and solution envisioning and all of the things that we want to do. It's more about storyboards, it's about use cases, it's about story points and user stories. There's a lot more that we want to do that gives us a richer feel for what are we trying to build, describing this intent. So how do we capture those? And how do we link those into the process and manage those as part of a requirements management approach? So we spent a lot of attention on those areas when you haven't got the luxury of yellow stickies in a room. And how we go through those and how we manage those and how we look at different aspects of that. And it is a little bit clunky sometimes. You do wish you could sit down at a table with a napkin sometimes. But we're not always in the luxury of being able to do that. And then, of course, like it or not, we still have to manage our projects to plans. When we started moving in agile directions, the classic situation was a product manager would go to the team and say, what will be released in 3 months with this project? And they say, I don't know, I'm agile. We have a 1-month sprint. I can tell you what's going to happen, and then after that, it's all a mystery. We can't plan that way. We can't work as commercial organizations that way. So how do we look at project planning at the higher level together with the project planning at the lower level of the teams? And how do those relate? And how do product managers and project managers working at this higher level get some comfort that they're still involved in the process, they still have a meaningful role, that they can still organize and plan and manage, while the project teams have some flexibility? How does that work? And to a large extent, this is the biggest problem about moving to Agile approaches. It's not at the development level, it's at the project planning, project management, project delivery level where we struggle the most. And we're still going through a lot of changes in our organization right now about how we do that, how we think about it, how we manage it. We're starting to see different ways of doing it. And then effectively we have to report that up to our management. Is this product ready to be delivered? We still have to answer that question. How do we roll up our tests, our verification testing? How do we roll up the information? How do we look at its trending over time? So it's a matter of essentially trying to warehouse that information in various ways. So we do several things. You know, one way to think about this is, if this was any other domain in software, we'd think of it as a business intelligence problem. We have lots of information from multiple sources over time. Okay? Data warehouse it, run a series of filters against it, run some tracking against those, against series of various metrics, display those in dashboards, make some decisions. Business intelligence problem, business analytics, that's what we do. Why not do that for our own domain? So this is what we've done. We've taken the Cognos business intelligence engine. We use that to collect information using extract, transform, load, pull stuff out, whether it's a spreadsheet, whether it's your favorite Microsoft tool, whether it's from our tools, whether it's from open source tools, warehouse them, run a series of filters against them. Which filters? Well, we know lots of things to measure. We don't have trouble finding things to measure. Go look at Capers-Jones, go look at Barry Beam stuff, go look at Cast and all those companies. There's lots of things we can measure. Pull those things out and start to look at how we can use those effectively. So over time, things have changed quite a bit. We've seen a big take-up inside our own organization of this sort of technology to enable us to collaborate, automate, visualize what's going on in our organization. We've seen the numbers inside Rational and across IBM improve quite significantly. The general process we use is a sort of amended version of a sprint kind of Scrum approach based on our lessons from projects like Eclipse, where we have a sort of special piece up front, which is to understand what we're doing, and a special piece at the end, which is we have to harden this up for delivery. There's points towards the end where nobody can suddenly start a new build or a new stream. No, you suddenly can't decide you want to break some of the sign-offs. Things become pretty important. So we tend to work in this kind of style. Again, we can talk at another time in detail about how this works. And in terms of what we measure, as I said, there's lots of things we can measure to look at, in quotes, the health of the situation that we're working in. And we use this warehousing. Here's an example of the kinds of information we're using in our projects to look at the development health. So you'll see, for us, we look at things like release health, perceived health, value. You might see some things on here about project completion time. We can look at the build health over time because that tells us a lot. We do things like we look at the revenue per product per release. So if this product that we've released is earning, let's make it easy, €1 million a quarter, and we have 100 people in the lab, is that good or is that bad? Should it be earning 2 million a quarter if there are 100 people? Should it be earning less? Is it in a development phase where they're still investing in innovating, or is it a product that's been on the market for a long time? Should we just ship all the code off to India to make it cheaper? You have to make those decisions. How you make those depends on information like this. This gives you some of those ideas, like percentage complete, schedule variation, headcount variance, and we can do slicing and dicing now by location, by project, because we've warehoused a lot of this information. We're able to treat it as an analytics issue. So we've improved significantly over what we did. Not all of this is due to Agile. Not all of this is part of that same improvement. We've done a lot of things around the product delivery process, but we're seeing changes in our own organization. And this is what we're using to also drive our own products as well. The products we deliver are software development and delivery products for other people. We use them ourselves. You'll see them used in jazz.net. And then we support those for our clients to also use. And at least it gives us some confidence that these products are useful and successful. I think that's probably about enough, more than enough. So I think I'm going to stop here. I have another 173 slides, but I don't think I'll show you those. I'm happy to give anybody who wants copies of these slides a copy with some more examples and so on. But maybe I should stop and see if anybody's awake or wants to ask questions. It's all clear as mud. Huh? En inglés, en español, como queráis. Puedo practicar mi español. Sí. You're going to ask the same question you asked the other day. No? Oh, man.
I was not maybe 3 weeks ago. No, I don't need it. Thank you. I need it. The boss said. Now the question is, all that information, how you can manage for gathering all that information for having those metrics?
Yes. So the answer is, of course, you have to start somewhere. And a question that often comes up when I talk with clients of various kinds is, this is all very nice, but tell me, what should I measure? And as Philip said, it depends, unfortunately. Now, I can give you some things that I think are useful measures, but measurements are used for a reason. So the first thing I have to do is say, well, what is it you want to measure? Why are you measuring? And measurements, you can do several things. You can measure simply because you want to see where you are. I want to just get something that gives me a baseline so I get a sense of where I am right now. And there are serious things you can measure. There are 5 or 6 core measurements that I think are key. If you look at several books, there's some very good stuff by Walker Royce that describes 7 key metrics. If you don't measure anything else, measure these 7 things. And they're about the product you're building and the release of the product. So it's obvious things, defect density. It's about requirements volatility. It's about, it's about test coverage. There's some obvious things that we know, that if you measure those things, you get a sense of where you are. So the first reason is, if you're not measuring anything, measure something. Measure what you've got. Whatever you can measure, measure it. Try and automate it because you'll get better measures, but at least measure something. The second reason you might measure is because you want to change somebody's behavior. We all know that if you want to do something in your life, let's say, if you measure it, it has an impact. There's, what's it called? Is it the Halstead effect? Is it the Hawthorne effect? When you measure something, you affect the measurement just by measuring it. So you say, look, I need to lose weight. I'll measure my weight every morning. It has an impact. I'll count the calories I take every day. It has an impact, right? Because you know you're measuring it, that later on when you're about to eat that chocolate cake, you say, oh, man. So things like that have an impact. So again, there's things, what behavior do you want to affect? Well, I don't think my teams are as productive as they should be. So you measure some things about function points produced per month. You start to measure some things about bug fixes per hour. Whatever it is, you start to measure some things. And it expresses what you believe in. So if that's what you want to do, there are a series of things you can measure in different areas. The third reason you might want to measure is because you're actually aiming towards something. So, for example, if you're trying to get to CMMI level 3 and you're level 2 today, there's a series of things you have to measure to see whether you're getting there. And it's to change your behaviors, and it's to change the way you look at your own organization. I can give you examples of situations where these measures were useful. And then I can see, if you're like this, measure these things, and this is what is likely to happen. But the answer is of what should we measure? There's no single answer, I think.
No, the question is not what to measure.
Why didn't you stop me earlier? I just spoke for 5 minutes on that.
No, because I know that you like to make big speeches explaining everything. Okay. No, the question is how you can pick the data.
Okay.
If you suppose that you have to have some of tools or some automation for pick up the data in an easy way. It supposes that it doesn't have to be an overload of work for the people that is involved on the project.
No, there are lots of things you can do fairly straightforward automations, you know, to count code, to every time you check something in, you can run scans. You know, the tools like that are relatively easy to obtain and relatively easy to put in place. So for example, that's what we do. We run code scans every time somebody does a check-in about security, about size, about complexity. Those sorts of things are not difficult. There are free tools around. We sell them. Lots of vendors sell them. And those can be put in strategic places in the development process, and they can automate a lot of interesting things. I think more of the challenge comes as to, there's a political aspect to numbers. So for example, I showed you a little bit of jazz.net. So some of our managers look at that and they say, Joe hasn't fixed many bugs this month. Maybe we should sack him, because he's the worst performing person in the team, if we look at the performance of it. So you say, well, have you investigated why Joe is not fixing as many bugs as the rest of the team? Well, it's because he's the worst person. No, he's the best person, and everybody goes to him to ask how they fix their bugs. They would have no chance of fixing bugs if they didn't ask him. So he's not fixing many of his own, but he's the key guy for fixing all the others. That kind of stuff isn't in the numbers. So the more difficult thing is not what can you measure, but what should you measure and what do you do with the measurements? And we're still in a lot of debate internally about how those things are being addressed.
Okay,
Did I answer the right question this time or no?
Okay, I think we have time for one question more.
Hi, I'm Manuel Noguera again from the University of Granada. I'm a little bit curious about one issue related to the thing you have been talking about lastly, and it is about motivation of group members. It seems as collaboration is a key issue, but I was wondering how in large teams, distributed developers, how people from India could feel motivated to work faster, because I think it also depends on the benefits he could or she could get from that. There's a famous piece of work from Jonathan Grudin. He's Canadian, I think, and I think the title is "Why Group Work Fails." You have been showing a group work application, and well, if you can tell us something about this.
Yeah, I think this is a fairly complex question, because several things are important here when you have globally distributed teams. The first thing to point out is, in these situations, the people are IBMers that happen to be in India. They're not another company. So the first challenge is, if you're organizationally distinct, you have some contract in place that can motivate people or demotivate people, depending on what the contract is. So there's a lot of discussion about what's the right way to write an SLA, a service level agreement, between one organization and another. How do you monitor that, and what incentives do you put in place? So there's a whole discussion about, for organizationally distinct situations with, particularly off-sourced providers, normally there's a series of, we want you to do this many function points over this much time, and this is the labor rate. Okay, well, the problem with that is, every time there's a change in your requirements, it means money to the system integrator. They love change. Change means money. So this becomes very complicated. So you get a lot of people talking about how you do, the initial bid up front is done as time and materials, plus once you get to a contract, it's done as fixed term. There's all sorts of combinations here that motivate behaviors between organizations that I haven't addressed here. And there's a lot for that side. The second thing is, just as dispersed teams, even if they're in the same organization, they work within different cultures, within different management structures, with different pay scales, with different relationships. And that itself becomes quite complicated. How you deal with and motivate teams in India is different from the teams in China, for example. So we have teams that I'm working with in China, and I don't want to be politically incorrect. We have a lot of conversations with these folks on the phone. The next day, they've been up all night and coded something. Look what we've done. We've been up all night. 20 people have been up all night coding this thing. We only had a conversation yesterday. It wasn't that we agreed anything. It wasn't that we, but they are so energetic. They want to go away and do this. And a lot of rather inexperienced but very, very motivated people to do something. But 90% of what they do seems to be completely wasted because it's not well channeled. And those sorts of things are very difficult to understand, both culturally, both organizationally, and I think also the politics behind it becomes rather complex because, you know, right now we've got a team in Ireland. I'm having huge problems because they think they're going to be outsourced to India. So they're treating me differently than they did 2 months ago. And they don't want to give the information to India because why should I train the guy who's going to take my job? You know, and you get all of this going on that is under the surface of many of these situations. And this is why I think it's a complex question. The examples I gave here are more straightforward, I think, in that they're IBM people working on a project with a relatively shared context. Once you get to some of these more complicated situations, you have to do some other things. And I think we talk offline about it, about how software factories work, how supply chains work, lessons we can learn from other industries like manufacturing industries. You know, there is quite a lot we can build on, but it's a very complicated question, I think. I'm sorry, I didn't answer it too well, but
okay.
It's a long way of saying I don't know.
Thank you, Alan, for your keynote. And